So welcome everybody to this special Biomedical Informatics and Medical Education Grand Rounds, or BIME 590 presentation by Professor Karen Verspoor, who's the Dean of the School of Computing Technologies in the College of STEM at Armit University in Australia. And to allow her maximal time for presentation, I won't repeat her bio or her summary of her talk, and we'll turn it over to you, Karen.
Thank you so much. I'm really happy to be here. And I guess I'm here partly to demystify ChatGPT. It seems like everybody is talking about ChatGPT. So I thought I would just take you through a little bit of detail on my thinking about ChatGPT and to unpack it a little bit so you know a little bit more about what it is and maybe cut through some of that hype that's out there at the moment. So, yep.
I'm not leaving yet.
So before I continue, it's common in Australia. Somebody's got their sound on. If you could put yourself on mute, that would be helpful. Thank you. In Australia, we acknowledge the Indigenous people of the countries on which we meet. And although I'm not currently in Australia, I did want to acknowledge the people of the Woiwurrung and Boonwurrung language groups where the university conducts its business, and acknowledge the Indigenous peoples of wherever you are today, and know that we respectfully acknowledge their rights to be on these lands. I want to take you back to 1981 in the household I grew up in, and maybe give you a little context for why I'm giving you this talk. So I don't know what you all were doing in 1981, but in my house, my parents brought home a game console called the Texas Instruments TI-99 4A, which was really, about playing educational games more than anything. But it turned out that this particular computer at that time, this game console, had a speech synthesizer. So we could do little fun things like this. So that was my start with getting computers to talk. And I think, what we're seeing now, many decades later, is the next generation of computers talking. And we're all fascinated by it. I think we've always been fascinated by computers talking, since the science fiction days and HAL 9000 and all of these. We've just always been super interested in what can we get computers to do. And particularly language has always seemed like this amazingly human capability that was very difficult, and indeed is very difficult to get computers to master. So, come on the scene, ChatGPT, and now we have this machine that, at least on the surface, seems like it is finally achieving that kind of objective of getting computers to talk. So what is it? Well, I put a screenshot here of what the OpenAI people tell you about what ChatGPT is. And in fact, it's a pretty good summary of what it is. So it remembers what a user said earlier in the conversation. It allows users to provide follow-up corrections. It's trained to decline inappropriate requests. And these are essentially guardrails that limit what it can say. And we'll come back to that a little bit later. And that's important because as it says on the right, it may occasionally generate incorrect information. It may occasionally produce harmful instructions or biased content, and it doesn't know everything. And I would suggest that it actually doesn't know very much, but that's again, something we'll come back to in a few minutes. So everybody, I think, has had a go at playing with ChatGPT. And I thought it would be illustrative to kind of give you an example of a little bit of playing that I did with it. So if you go into ChatGPT, or at least when I went into ChatGPT and typed this prompt, fairy tales in which the hero must overcome an obstacle, ChatGPT responded with a very nice summary of essentially Disney-esque fairy tales, and a brief little description of why the main character in that fairy tale overcame what the relevant obstacle was. Now, if we take a sort of critical look at this list, you can see sort of immediately that it's quite biased, right? What we're seeing here is Western fairy tales and, the sort of most common fairy tales that everybody would have been exposed to growing up. So that's kind of the first sort of, indication that what we're getting in response to this prompt is really just a reflection of what is in the model that underlies ChatGPT. And if we dig a little further and we continue the conversation, because as we said, we're allowed to kind of build on one prompt and have multiple turns in a kind of discussion, in a conversation with the machine. The ChatGPT dutifully responds, sure, here's a short fairy tale I came up with. And if you read through this, I won't read through the whole thing, but if you read through it, you notice that there's a very kind of explicit statement of the purpose of this fairy tale. So knowing that he had overcome the obstacle of the mountain and achieved his dream. And then there's again a very kind of pedagogical kind of summary of the whole purpose of the fairy tale, and doesn't leave a whole lot of room for individuals to draw the conclusions. He had also discovered a new appreciation for the beauty of the world around him and a sense of confidence and self-belief. Personally, I don't think this is a very interesting fairy tale, but there are some interesting aspects of it. So obviously, ChatGPT is able to produce very, very fluent prose. And indeed, it's able to handle some fairly sophisticated aspects of language. So it can retain the context of the previous interactions. It's doing something called reference resolution, which I'll point out again in a minute. But on the flip side, the story itself is rather short. As I said, I don't think it's a very good one. It's quite formulaic. It never describes the motivation that Timmy has for overcoming the obstacle in the story. And it's doing a lot of a lot of telling rather than showing, which is typically what we like about stories, is that we are able to draw our own inferences from the story rather than being told what we should be interpreting from the story explicitly, as it has done. Now, this point about reference resolution is an important one. If you notice that the prompt that I gave it was very general, right? Write me one what? Well, in the context of the previous prompt, it's clear that one is referring to fairy tale. And actually, ChatGPT has understood that connection, right? It's expanded the word one and turned it into fairy tale. And in fact, it goes even further and recognizes that one actually refers to the entire context of having a hero that overcomes an obstacle, because the story itself very explicitly incorporates that element. So in fact, one here is a fairy tale in which the hero must overcome an obstacle. But I would suggest that ChatGPT isn't very interesting in terms of what it produces. Producing very highly generic responses, lacking specifics, very literal and formulaic. And you can find this yourself if you try various things. In the context of medical applications, we see this behavior as well. So I went into ChatGPT and I asked it to create a treatment plan for a patient in acute pulmonary edema. And what it responded with was a treatment plan, which involved going to the emergency department, running a bunch of tests, and then deciding on medication. Now, if you're asking this kind of question, asking for a treatment plan for a patient with a particular diagnosis, actually, I'm assuming that this patient is already in care. Otherwise, we wouldn't need a treatment plan, and that we've run the diagnosis to determine that the patient already that is in acute pulmonary edema. So the first two steps of this response are actually completely irrelevant to the scenario that's been presented. And then from there, it's just far too general. Depending on the underlying cause, medications may be prescribed. Well, that's not really particularly helpful. What medications? What are the pros and cons of them? It's not really giving us the answer that we need. So again, highly generic and very literal. And the reason for this is ChatGPT is basically an amalgamation of everything it was trained on. It has indeed ingested a huge amount of text, most of which is English. And it's been trained to capture patterns in language use based on complex examination of word sequences. And if we pare it right back down, all it's trying to do is to predict the next word of a sequence. So we can all play this game. If I ask you to predict the next word in the sentence, the cat sat on the, I'm going to guess Matt was the first word that popped into your head. Of course, there are other options for things that could go into that blank. It could be the pillow, it could be the sofa, it could be the chair, it could be the blanket, it could be all sorts of things. But probabilistically, the most likely word in that sentence is going to be Matt, because that's a pattern that we have heard over and over and over again over the course of our lives. So effectively, this is what ChatGPT does. It by being exposed to large amounts of text, it infers the patterns of word sequences that are highly probable in those texts. So let's unpack a little bit what's going on under the hood. GPT itself is an acronym, and it stands for Generative Pre-trained Transformer. So what do those words mean? Generative. Generative is a model that generates text, in this case, in response to a prompt. Pre-trained means that it's been created by ingesting a huge amount of text, and that statistical patterns in those texts have been summarized in this very large and complex model. But once it's been trained, it's fixed, and the statistics themselves don't change unless you do something to adjust it further. Transformer. Well, transformer is a particular kind of architecture for doing the pre-training. And so it's a statistical learning algorithm that uses something called attention to allow the model to pay attention to all of the words simultaneously, which I'll come back to. So in a little bit more detail, generative. What we're trying to do is predict the next word in the sequence, just like we did. The cat sat on the, what's the next word that's most likely to follow? That's exactly the model that ChatGPT is following. So it's exactly like predictive text on your phone, extended to much longer text and based on much, much bigger and more sophisticated models and much more training data. Pre-trained. Okay, so this is about learning representations of words and their distributions from that data. We feed in lots and lots and lots of data. We produce vectors for each word, which captures all of that data and summarizes it in what can be thought of as a lower dimensional space. So we're taking the whole space of all of the text that it's been fed and trying to produce a more compact representation of the patterns that are implicit in that text. The basic intuition here is that we're inferring mathematical features for each word based on the patterns in the data. And to give you a sense of how this works in practice, the model uses something called masking. So as the model is being fed the text, we hide particular words in the input. And then what we ask the model to do is to try to guess the right word in that input. So if we feed in the cat chills blank a mat, and we ask the model to try to guess what goes in the blank, and it puts the word on in that blank, we will give it a positive reinforcement. We will reward it so that it will be more likely to produce on in that kind of spot, in the position in the future. If, on the other hand, it inserts a word that doesn't make sense in the context, like the word jeju in this example, then we would penalize it and essentially train it to reduce the weights, the likelihood that jeju would be produced in that particular slot. So we repeat this kind of approach over and over and over again. And eventually the model settles on the right probabilities learned from all of those data. And we can play this game with the model ad nauseum, essentially, because we have so many examples of real patterns in the world that we can always check, did this occur in any sentence out there in the world? Okay, this transformer model. So what are we doing actually inside of this model? As I said, we're trying to produce a lower dimensional or compact representation that mathematically encodes the essence of the input, all of those patterns. An encoder model is about transforming those inputs into that representation, and a decoder model takes an encoded input and turns it into an output. And in typical deep learning models, we stack many of these encoders or decoders on top of each other so that that sort of reward and penalty mechanism results in very complex interactions of weights being put together. So essentially the model, each of these encoders or decoders is trying to capture some characteristics or some set of patterns within the data that's been fed in. And the objective is to learn those weights, right? How to weight each part of the input data, for instance, the words in a sequence, in order to capture the differences in the importance of each of these parts. And the real trick that has happened with transformer models, and by the way, the original transformer model was proposed in work by Google in about 2018. And it resulted in a real step change in how well these models worked. And the reason for that is that they simultaneously consider all of the words in the input. So if you think about our example, the cat sat on the mat, we were thinking of it in a very left to right way. We were only considering the words that came before when we were predicting the next word in the sequence. But you could also imagine that if you're feeding in a whole bunch of text, you can have the model look backwards as well, or indeed look at everything together. So let me illustrate this a little bit with the help of some figures that I found on a couple of blogs that are cited there below. So if we're using this kind of approach for machine translation, we would have a series of encoders which are stacked together to try to capture that representation of the input text, in this case, the French, je suis étudiant. And then we would use that encoded representation and then try to decode it in order to generate the corresponding output in English. I am a student. Adding in this notion of attention in the transformer models actually means that we start to get influences or weights from all of the words in the context to help us either do encoding or to do decoding. So at every point in time, we're actually considering the influence of all words in the context on the probability of a particular word. And as I said, this was kind of a key contribution that was made through these transformer models. And it really means that the models can handle very subtle kind of variations in interpreting words or representing words in particular contexts. So it's quite an effective way of handling things like ambiguous words that are difficult, that may have different meanings in different contexts. And when I say meanings here, I really mean patterns of use that go together. So a word like apple, which of course is a fruit in some contexts, or the technology company in other contexts, will have the right kind of representation in terms of the mathematical weights in the particular context, because if we see it in a food context, the words that have to do with eating or snacking or what have you will influence the probability and the representation. Okay, so ChatGPT is a generative pre-trained transformer model. And in this particular case, it employs only a transformer decoder model, which means that its focus is on the generation side of things. And it uses the prompts as the context for the starting point for generating the next word in the sequence. And so at a fundamental level, ChatGPT-3 or ChatGPT is just following this kind of predictive, what's the next word in the sequence kind of model, while leveraging the model that has attended to all of the words in the context. So the likelihood of a particular word being generated is influenced by all of those patterns that have been observed in the training. So we use that prompt to try to drive the generation of the words. Okay, now actually what I've described there and the notion of ChatGPT or GPT simply focuses on that generative model. In fact, what's happened with ChatGPT, and one of the reasons why people have been so impressed by it, is that they've incorporated a lot of human feedback into the training. And again, this is a screenshot from OpenAI themselves. So they've been quite honest and open about how exactly they have gotten ChatGPT to go beyond the original capabilities of the models like BERT and BART, which were generated, which were built by Google. BERT being an encoder model and a transformer encoder model, and BART being a transformer decoder model for generation. They've added on top of that a lot of very explicit human feedback. And actually in the first stages of developing InstructGPT, which is under the precursor to ChatGPT, they had humans write the correct answer, if you will, to a particular prompt. So they created a whole library of prompts or questions or statements that might be expected to be fed into the system, and asked humans, what would you say in response to this prompt? And so over here, what we have is a human actually demonstrating or writing a response to a prompt that captures how a human would respond to it. And that then is used to what's called fine tune, or basically adapt the outer layer of the weights in the GPT model with that human feedback to guide the kinds of outputs the system will produce in response to any given prompt. And they do this over and over and over again. Eventually, the model gets good enough that they are able to move into step 2 here, where they're actually allowing the model to generate several different outputs, remembering that it's probabilistic. So sometimes in response to the same prompt, it will generate variations, different kinds of answers. And so then they allow the model to generate multiple responses to a given prompt, and they use the human feedback to rank those outputs. And again, that ranking is then used to drive the reward or penalty feedback that is fed back to the model, so that the weights can be adjusted further and refined to prefer the kinds of outputs that humans prefer. Finally, they do another stage of reinforcement learning where, again, they use human feedback to guide the final outputs. So the key message from this particular slide is that there's an incredible amount of human in the loop process happening, and it's a misnomer to think about the model underlying ChatGPT as being entirely learned just by reading the text themselves. We need a lot of human input to get it to actually produce the sorts of outputs that are meaningful to humans. So in a nutshell, what ChatGPT is a very competent generative language model, meaning it produces language that actually sounds good. It is a very large, sophisticated mathematical representation of patterns of word sequences, derived from massive data sets of example texts. And we don't know how big, but we know it's big, and improved by large amounts of human feedback. And there's an idea that was proposed a few years ago by Emily Bender, who happens to be a professor at University of Washington right here in Seattle, and colleagues from Google, including Timnit Gebru and Melanie Mitchell. And they wrote a paper describing these sorts of large language models as stochastic parrots. The idea is that the models essentially learn how to parrot back the meaningful word sequences by having examined large amounts of example text. And indeed, Emily is doing a fantastic job out there in social media, trying to fight the notion that chatbots are anything more than just a stochastic parrot. So she says, you are not a parrot. And that, by the way, that's also something that's been happening, is that we've been essentially trying to explain the linguistic capability of chatbots like ChatGPT by dehumanizing humans and saying that that's essentially what we are as well. I think I agree with Emily that, in fact, that's not a very complete view of what humans are doing when we learn language. And why is that? Because if you dig a little bit under the surface, ChatGPT is not actually understanding language in the same sorts of ways that you and I understand language, or what's happening as I'm speaking to you and you're trying to understand the words that are coming out of my mouth. What we do naturally is abstract and generalize from the words to infer a kind of conceptual representation of the key ideas that are being spoken, rather than the actual words. If you try to remember an hour from now any individual statement that I made during this talk, my guess is you probably won't be able to do that. So that's because we abstract, and what we're thinking about is concepts and relationships between those concepts, and this higher level kind of representation of meaning, which just doesn't exist in what is effectively a statistical and mathematical representation of text. There's no explicit reasoning, there's no explicit inference, and of course, there's no connection between anything that's inside of this model and anything in the real world. And for human language understanding, that's actually a critical part of our ability to use language, is knowing what the things we're talking about when we use words refer to in the real world. Now, obviously, we have abstract concepts that you can't point to in the real world, but we are able to do that through this higher level thinking and abstraction that we can do. And our basic learning of language is grounded in the real world, and we have to build up to the competency of more abstract thinking. Kids, for instance, will talk about things that are immediately in their environment, right? They'll talk about their milk and their mom and their favorite bear toy or a book. They don't start talking about, honesty and integrity and justice until they're a little bit older. ChatGPT is also not entirely factual or reliable. Why is that? It's generating statistically likely patterns of words. But just because a sequence of words is possible statistically doesn't mean that it actually captures anything that's real, that reflects a true thing in the world. And importantly, the model itself is huge. And because it's a mathematical representation, a mathematical sort of condensation, summation, aggregation of a huge amount of training examples, we can't unpack it and look inside and pick out anything explicitly that corresponds to particular words or particular concepts. It's a very, very sophisticated mathematical representation of all of these complex patterns, but there's no explicit element in there or node in there for milk or mom. It's just not something we can look inside and see. And what else is it not? Well, there's been some talk about ChatGPT being sentient. I don't know about you, but I find that pretty far-fetched. It's not a cognitive agent. It's not understanding these abstract concepts and entities and relationships, and it definitely doesn't feel things. I've also heard people say that ChatGPT learns language the way people learn language. And I think you can pretty easily refute that claim by thinking about the fact that children learn language, yes, through exposure to language over and over and over again, but not by feeding in billions and billions of words into their brains. we actually do it fairly systematically and in fairly limited ways. In fact, if you set up a context and try to get someone to learn a new word for something, they can learn it almost instantly. And it has nothing to do with being exposed to that word a million times before they can build a representation of how to use that word correctly in context. And again, that's because we are able to generalize. So once we understand the properties or the characteristics of a particular real world entity that we're trying to learn the word for, we can generalize from other similar words how to use that word correctly. So we learn very, very quickly, and it doesn't take millions of examples of a particular word in different contexts in order to get us there. Okay, so I also wanted to highlight a few things that I think you need to understand beyond the mechanism of how ChatGPT works. So again, OpenAI tells us this is a free research preview, and their goal is to get external feedback to improve the systems. And they have safeguards in place, but the system may occasionally generate incorrect or misleading information or produce offensive and biased content. Now, they warn us about this explicitly on the OpenAI website, and yet everyone is trying to use ChatGPT for exactly the purposes of getting advice or getting information. And in fact, I've heard people talk about, oh, we're not going to need search engines anymore because we can just ask ChatGPT to summarize the information that we're looking for. But in a context where it's producing incorrect or misleading information, or indeed harmful information, I think we need to be very wary of this tool and over utilizing it. This issue of lack of understanding is an important one. Here are some examples, which by the way, they fixed now. So, that tells you that even though they've told you the system was frozen as of 2021, not quite true. But anyway, at the time these examples were floating around, they sort of raised some obvious problems with the ChatGPT model. So a question here that was asked by someone, what will be the gender of the first female US president? The response that ChatGPT gave, by the way, the answer to that question is right in the question, right? The gender of the first female US president is female. Anyway, ChatGPT can't answer the question and asserts that there has already been a female president of the United States, specifically Kamala Harris. Well, I guess that's not true. Other examples along the same lines, sorry, don't know why it's not progressing. Okay, what will be the gender of the first female US president? Same question, different answer. Remember, it's a statistically generated response. There has already been a female president. This time it's Hillary. Hillary Clinton was the first female president. The question, what is the average height of female presidents of the United States? Obviously, there is a presupposition error in that question. It's intended to trick ChatGPT, but ChatGPT doesn't catch that and just plays right along. There have been 4 female presidents of the United States, and then goes on to list them. Of course, we can't capture their height because we don't know much about their height. Yeah, probably not the answer that it should have given. So let's think about what can go wrong in this kind of model. First of all, despite the name of this company, OpenAI, very limited details have actually been provided about what's in ChatGPT. And what we do know is that it will generate incorrect information or harmful information. They've told us that themselves. And that's because if it's being trained on very biased information, and it's learning the patterns of word usage in that biased data, then of course it's going to produce similar patterns in the output. So if there's bias in the input, there's going to be bias in the outputs. And they can put guardrails around that, but it's still the default behavior of the system. The other thing is that we can see that there's an incredible amount of English, and the bias in language is towards English in the system. That's not to say it doesn't produce Spanish or French or Mandarin or other languages, but the real sort of strength of the tool is in English. And for other purposes, it's not as reliable. Furthermore, it is out of date, right? So it is not dynamic, at least in principle. And the sort of the pre-training of the model is reliant on these data sources from a couple of years ago, which means that as, you know, as things evolve and we have new people come on the scene, and we have new words that come in and new terminology that's coined, the system will inevitably be out of date. And so we have to think about ways to allow it to be dynamically updated. There are also some serious ethical issues that are associated with the model. One question is, who owns all of these words that are being used to train the model? It's very clear that there is substantial copyrighted material and other intellectual property of content producers, writers, artists, journalists, and these have been utilized without permission. And as a stochastic parrot, ChatGPT will just quite happily produce things which are in the style of a particular writer who may very well be very alive and quite annoyed that ChatGPT is imitating their style. Who ultimately is responsible for words it produces or the harm it might cause? If it's generating hate speech or just generating incorrect statements, misinformation, that can have real world impacts. Is OpenAI going to take responsibility for that? I doubt it. What about the ethical treatment of the people involved in that human intensive training process? We've already seen some articles that talk about low paid gig workers in third world countries being employed for this. And some of these things interact. So for instance, the human trainers were exposed to very biased and hateful language that they then had to give feedback was not appropriate. But that actually has impacts on the humans who've had to read this garbage it was spouting. I want to come back to that comment I made about replacing a search engine. In my opinion, we cannot replace the search engine with the current generative instantiation of ChatGPT, because what we're talking about here is a statement that has been generated based on statistical patterns, and we can't vet. There's no real source of that information, right? The source is this statistical model, which will produce patterns that match our expectation in terms of the linguistic structure and make sense in terms of the linguistic competency. But in terms of the actual sort of real world understanding of that pattern, there may be no real credible source for that information. And if there is a source, it isn't tracked. And we do know that ChatGPT will parrot back things that it has read, sometimes verbatim, but the source of that information is not provided to us. The information may be entirely confabulated, or people have been using the word hallucinated, and therefore factually untrue. And you can find examples of this very, very easily. In fact, when I gave a talk last week, somebody asked ChatGPT to generate a bio for me, and it included numerous facts, which, while plausible, were not actually true. For instance, it said that I had been awarded the prestigious Australian Research Council Future Fellowship, which in fact I never have been, because I actually timed out of being able to apply for that particular fellowship. So I couldn't have even been awarded it even if I had applied. As users of a search engine, we implicitly critique the source and the veracity of the information that the search engine brings back. And because there's no source for the information that ChatGPT is producing, we lose the ability to do this. So if we're searching for medical information and we're given a link to the Mayo Clinic, we will implicitly trust that information more than if we're given a link to, I don't know, a Reddit post on a particular disease topic. I'd also like to give you some examples of, in fact, where the linguistic limitations become apparent. And these things will improve over time as more and more of these examples kind of come to light. But it does beg the question of, do we need to have a kind of higher level abstraction of language rather than just a stochastic parrot? If we look at this example, Barbara, Mary, and Harry had red balloons. Ted had a blue balloon. Sam also had a red balloon. How many children had red balloons? ChatGPT tells us which children had red balloons. So that's actually pretty good. In total, there were 5 children with red balloons. In fact, there are only 4 in that list, so it's a bit funny. And overall, things like numbers and mathematics are very difficult for ChatGPT. Now, of course, we can build a calculator or we can build some targeted mathematical numerical processing into ChatGPT, but the idea of using a statistical pattern generator to do mathematics just doesn't quite fit. Other examples where the sort of inference processes become problematic are things like this one. Morton was not unattractive. Does it imply Morton was attractive? ChatGPT confidently tells us yes. If Morton was not unattractive, then it implies Morton was attractive. But those of us who understand the nuances of negation will say, well, being not unattractive doesn't really mean that you are attractive. It just means that you're at least not attractive. You might be very plain, which is also not quite the same as being attractive. So the logical reasoning here isn't quite right. Here's another one. Not 1, not 2, but 3 of them made the mistake. Does it imply one of them made the mistake? Well, ChatGPT says no. But of course, we know, because we understand reasoning under negation, that if 3 people made a mistake, then at least one of them made the mistake. Here's another fun one, which involves that abstraction ability that we have. If a man owns a dog, entails a man owns an animal. Does a man does not own a dog entail a man does not own an animal? ChatGPT again confidently tells us, yes, this entailment follows. And it gives us a long explanation for why, which is, of course, incorrect, because there are other types of animals besides a dog that the man might own. There are some other examples that are even more complex for a system like ChatGPT, and this has to do with situating language in a context. Things like humor and sarcasm and metaphor are very, very difficult for a system like this. And ones that have to do with the environment that we're in, or the place in which we use language, is really almost impossible. So if you imagine a waiter in a restaurant, and there's a man in that restaurant who has ordered a ham sandwich, the waiter might say to a colleague, hey, the ham sandwich wants more coffee, which is more specific than saying, the man over there who ordered the ham sandwich wants a coffee. I asked ChatGPT, in that scenario, does it make sense to say the ham sandwich wants more coffee? And ChatGPT says, nope, you can't say that, because guess what? Ham sandwiches are inanimate and they can't want coffee, which superficially is true. But in the particular context in which the statement was made and that scenario, it actually makes perfect sense to be able to say something like this. Okay, so as Peter mentioned, we have now this new ChatGPT 4 that has been announced this week. And we can see from the evolution of the technology that the technologies are only going to get better, right? We're producing more and more human-like responses. They're incorporating more specific information. Again, we don't really know what, because they're not telling us, but it's clear that they're covering more domains. And so in fact, the information is becoming both deeper and broader because it's covering a wider range of things. ChatGPT 4 now is multimodal, so it's coupling image processing with language processing. And it's been shown to ace a number of standardized tests, including in medicine, the bar exam, and an MBA exam at Wharton. So the superficial abilities of the system to handle these complex questions that humans sometimes struggle with is getting better and better. However, along with this, real concerns are being raised about unintended consequences of these technologies. And there has been some proposal to really think about the risk that is caused by technology like this, and what gets perpetuated through these sorts of models. As I said, bias in, bias out. So if we're training our models with a lot of data and text that's coming from harmful actors or misinformation, think about the Cambridge Analytica scandal, right? Where there was intentional disinformation that was placed into the public sphere. If our models are being trained by this, it's just going to perpetuate all of this misinformation. We need to be thinking about what the risks are of this technology. And there's some examples which were included in the ChatGPT 4 98-page paper describing the technology, where in fact they don't give many details about how it works, but rather what it's doing. And they provide, it's too small to read, but you can find there some example prompts that they acknowledge led to harmful content, which they then had to use human feedback and human effort to try to remove. And if you go to ChatGPT, you will often stumble into, I'm sorry, I can't answer that because it would be inappropriate. And this is where they've had to explicitly look for things that are identified as being harmful and remove it from the capabilities of the system. There was some work that was done last year on the use of AI for doing drug discovery, and GPT-4 in the documentation talks about these kind of drug discovery and capabilities. And in the paper that I've highlighted there, they showed that in fact, as soon as you have an AI that can be used for drug discovery, it can be misused for design of biochemical weapons, that is biological warfare. So we have to be really careful about how we look at these kinds of models and what we want to use or what we try to use them for. I'll probably leave it there to give some time for a bit of discussion. But just to summarize the points that I've been trying to make, ChatGPT produces remarkably fluent text and is really amazing as a linguistic machine. However, we have to approach its outputs with a critical lens because it confabulates, it makes things up, it doesn't provide sources for its information, and fundamentally, it is a word-level model, but not a world model. So you and I are always trying to tie these words that we use to our understanding of the world. And ChatGPT and models like it fundamentally do not. We need to consider how we can govern the use of this sort of technology and make sure that it's used safely. Of course, we have to acknowledge that it's only going to get better and it's getting better all the time. And so therefore, putting all this together, we need to find ways to use the technology in safe and meaningful ways, not ones that are going to lead to further harm. So with that, I'll leave it there and say thank you for listening.
Great. Thank you so much, Karen. That was outstanding. Just for efficiency, I've asked people to put their questions into chat. If you want to, you could switch over so that you can see chat perhaps. Yep. Because there's two questions from Eric Rose, and I'm sure there will be a couple of other questions now that you've wrapped up.
Sounds good. Okay, let's see. I'll read the first one. Eric Rose, why can't the reward model be used to generate the output rather than the PPO model? If the former is being used to train the latter, it sounds like the whole approach assumes that it is closer to understanding what optimal output would be. Okay, so this is quite a technical question. If the former is being used to train the latter, sorry, I have to do my reference resolution here. So oh, why can't the reward model? Okay, so It's closer to understand. Yeah. So, I mean, it's an iterative process, right? And what they did, I think your question is about like, why did they start with the human output as the starting point? Is that what you're asking? Or maybe can you come off?
So I apologize if my question is obscurely phrased. And it may be my lack of understanding of how ChatGPT works. It sounds like they used human labeling to build the reward model, and then they use the reward model to train the PPO model. And what I'm wondering is why not just use the reward model to generate the output if it's, to put it simply, smarter than the PPO model, but maybe it's that the reward model isn't, the way it's designed, isn't capable of actually generating text. It's just capable of telling you whether the text, assigning reward or reward points or something.
Yeah, no, that's right. So the reward model itself is sort of just at those outer layers of like basically which particular outputs you will prefer, right? So it's not doing the generation of the text.
Okay.
It's about optimizing the final selection of what's output, if that makes sense.
Yeah, it's a professor who can grade papers but can't write. I got it.
Yeah, exactly.
Thank you.
Okay, and you had another question, which was around following explicit instructions. Yeah, so I saw a great video about this from an English teacher, which asked ChatGPT to generate a sonnet in the style of Shakespeare without using the letter E. Now, it turns out that Shakespeare actually quite commonly would sort of manipulate the spelling of words in order to make things sort of match up in his sonnets. And so ChatGPT did exactly that, but failed to remove all of the E's. So there were still, here and real and other words that have lots of E's in them. And indeed, that's a very, very difficult kind of thing to do, right? Because the letter E is one of the most frequent letters in English spelling. But it just, because it doesn't have that abstraction about the meta language, in that case, your example is the same, right? On a topic with exactly 10 syllables. And, these sorts of instructions require that abstracted understanding of properties of text, which are difficult because ChatGPT doesn't actually have a model of language. It has a model of sequences of words. Does that make sense? Okay, and I'm being asked for my slides. Yes, I can do that. With the addition of images, do you think ChatGPT-4 has an understanding between real world entities and terms? Well, I mean, pictures of things in the real world are also not things in the real world. So it all comes down to what we think of as understanding. And yes, we can start to ground words in images and build, statistical associations between them. Is that understanding? I think there's a highly sort of philosophical debate that we need to start having about what exactly does understanding mean. But for me, understanding involves abstraction, categorization, and concept representation, which is not part of what's in these models, at least not at the moment. So, when we think about knowledge, as I said, we think about entities and relationships between entities, not just statistical associations. So part of how we define words is the categorical information. That example of a dog is an animal. Just because the word dog and the word cat are kind of substitutable in the same context doesn't necessarily mean they both belong to the same category. And without an explicit sort of representation of our understanding of the relationship between dogs and cats as types of animals, and particularly domesticated animals that you might have as pets, it's unclear that the model sort of understands these words in the same way that you and I do. Have I considered the use of chain of thought prompting or other prompting strategies? Some of these approaches can mitigate. Sure. So, I mean, the thing is that we can we can, even in the examples I gave you for reasoning under negation, we very carefully sort of explained to ChatGPT what it was that we were looking for. And by the way, that was done by my student, Tin, who is working on negation in large language models for his thesis topic. And, we can sort of very carefully construct these ways of using ChatGPT. But I think there are two problems. One, we don't really understand what is in the model, which kind of limits a little bit to how we can think about how to use it. But second of all, the chain of thought prompting is again, doesn't imply any kind of actual logical representation of that chain of thought. It's just the word sequences that correspond to that chain of thought, which put the model sort of into the right space. But it doesn't have that abstraction capability to really understand the chain of thought, as it were. It's not representing a chain of thought. It's representing a chain of words, which we've given it. So while we can manipulate the system, to address those concerns, we are interpreting it using our understanding, not ChatGPT actually understanding what we're asking it to do, if that makes sense. Okay, Trevor asks, how would you respond to students that are demoralized by the successes of commercially trained large language models? Right. I mean, look, we all struggle with this in academia, don't we? Because we don't have the resources to train these massive language models. And the commercial ones, are problematic because actually we don't have the ability, without paying a lot of money, even to test them and evaluate them for our purposes. This week, many of us are attending the American Medical Informatics Association Informatics Summit here in Seattle. And it's come up that actually running patient data through ChatGPT is not allowed because of patient privacy, and actually taking patient data and sticking it into a commercial tool creates problems. So we're probably not going to be able to work directly with these commercially trained large language models either. And on the other hand, training them ourselves is cost and resource prohibitive for most of us. So is that demoralizing? I suppose, but I guess, what I would say is that maybe we need to be thinking about the tasks that we're asking our students to work on. I don't think that just showing that minor modifications to the architecture or the methodology that's in a large language model will have an incremental improvement on a benchmark data set is necessarily a good use of anyone's time. We'd like to really sort of go deeper into new problems or new tasks or ways we can harness the existing pre-trained model to solve new problems. And so I'd like to see us, maybe not trying to compete with these commercially trained large language models, but rather work out how best we can use them and also work towards that safe use and meaningful application. They're not going away, and they are there. And we know that their linguistic capabilities are amazing. But the gap between the linguistic capabilities and the real world applications in which we want to use them is still quite large. And I think that's where we need to put our efforts. Peter has a question. Okay, in relation to putting a large amount of data sourced from different points in time, yes, where probabilities of associations change over time. Right. Okay, so ChatGPT, basically all of these models are built by just throwing all the text in and producing this model. And absolutely, there's no representation of dynamics and time series. So again, it's not building a representation of information. And so, if we had categorical information that corresponded, to use your example, a list of planets, and we were representing that explicitly, then we could potentially model that list was different at time 0 as compared to time 1. But there's no explicit representation of that. And so indeed, in the context of knowledge change, which is, you know, a constant in science. That's kind of the whole point, right? Science is always adding to our knowledge base and our understanding of the world. As that happens, we are not going to be able to even represent that in a model like this one. It can be mitigated a little bit by trying to, you know, assume that text at certain times may have been explicitly time pointed, right? Like you have sentences that say, you know, in 1981, this was known, and then, you know, in 1990, some new information came to light.
Right, but using the example you gave about treatment of pulmonary edema, you know, as someone who has done a fair bit of evidence-based medicine work, Bayesian decision support systems, et cetera, medical knowledge continually evolves. And
Absolutely.
the bulk of medical knowledge, if you think about it, is incorrect because it's the leading edge that's correct, but the older information has been subsumed by the newer information. So if you put in a statistical model, it's going to do pretty well, except it's unlikely to catch the most current treatment for anything. Because that's not the most current treatment is the least likely to show up in an association with, you know, what is the treatment for breast cancer? You're not going to get the latest treatment. You're going to get the most common treatment.
Yes, and it's not going to be contextualized to the specific, you know, case of the patient and so on. Yeah, no, that's exactly right. Nothing is contextualized in these models. And as you know, the example with the fairy tales, it's kind of a little bit of a glib example, but at the same time, you know, it's extremely generic. The information that you get is an aggregate of everything, and you just get the most likely thing. The most likely thing is not necessarily the most salient thing or the newest information, for sure. Again, because there's no explicit representation of knowledge in there. Okay, well, it seems like we've run out of questions and we may run out of time.
Yeah, I think we're over time. I don't know. I bet if you stayed on, there would be more questions coming. Although now that you've said that, people are now saying thank you. So
look, I'm completely happy to stay and answer a few more questions. But you know, if there are no more questions, that's fine too. And yeah,
you're getting lots and lots of thank yous, and you peaked out at I think like 67 or something. So we did get a lot more popcorn popping after you started. But
excellent.
Thank you very, very much, Karen. There is one last question, and I'll email you a couple of follow-up questions, logistical questions about the recording and the slides.
Sounds great.
Leanna Wu has a question going back a bit from the first couple of slides.
Yep. Okay, going back a bit from the first couple of slides, ChatGPT seems to be dependent on good input, i.e. no spelling errors. What does that, how does that factor or affect the stack of encoders or mathematical weights? You know, because it deals with statistics. If there's a word in there or, you know, something it doesn't recognize, then it will kind of effectively ignore it, right? Because if there's something in the input that hasn't been previously observed, then it just sort of doesn't impact too much the sort of interpretation of the other words. So does the encoding include a process of proofreading? Not explicitly. So, you know, there's no explicit kind of correction of the input that's happening, but because you know, the correct spellings are more prevalent than the incorrect spellings, you know, effectively, if you have two versions of a word, one of which is spelled correctly and one of which is spelled incorrectly, they will be treated as different words, but they'll be, because they're used in similar contexts, they'll sort of, you know, be similar in the space. So it's possible that there'll be influence of the misspelled word on the correctly spelled word through that attention mechanism, and the representation. But in practice, you know, if you have like a very unusual misspelling of something, it effectively just sort of disappears, if that makes sense. Okay, well, that might bring us to the end.
No more chat, so I'm assuming that makes sense. I'll go ahead and stop the recording. Again, Karen, thank you so much for taking the time to put together this very, very timely presentation.
You're welcome. Thank you all for listening. All right, take care.